Have you ever wanted a personal AI assistant that's just always there, always on, but doesn't need some huge, power-guzzling server? I mean, what if you could have all that on a tiny piece of hardware that costs just $5 and is literally the size of your thumb? Well, that's exactly what we're digging into today, a wild project called MimiClaw. When we picture AI, our minds immediately go to these massive data centers, right? Racks and racks of servers burning through electricity. But MimiClaw flips that whole idea on its head. We are talking about a gigantic leap from a server farm down to a single chip that sips just half a watt of power. It's a totally different way of thinking about where AI can live and what it can do. And that's the big, bold claim right there. This isn't just some weekend project, it's a statement. It's about making AI personal, portable, and ridiculously efficient. So the big question is, how on earth did they pull it off? Okay, let's break it down. What does it actually mean to have an AI on a chip? How does it work? And, what are the trade-offs? So at its heart, MimiClaw is this clever bit of software that transforms a tiny, super cheap board, an ESP32 S3, into your own little AI buddy. Getting started is dead simple. You just plug it into a USB port, hook it up to your Wi-Fi, and then you can chat with it from anywhere using Telegram. It remembers what you talk about, it learns about you, and it can even take initiative. But, and this is the big catch we'll get into, while all the logic runs on the chip, the really heavy-duty thinking still happens by connecting to a big cloud AI, like GPT or Claude. So how do you possibly cram an AI assistant onto a device this small and this low power? Well, the secret is this really hardcore philosophy of simplicity. You basically throw out everything you don't absolutely need, and that starts with the entire operating system. Look, if you've ever played with a Raspberry Pi, you know it's basically a tiny computer running Linux. MimiClaw's approach is the total opposite. They get rid of all that overhead. There's no Linux, no Node.js, none of that. It is just pure, efficient C code running right on the hardware. That's what makes it so incredibly fast and lightweight. This approach has a name. It's called bare metal programming, and it means exactly what it sounds like. The software is talking directly to the silicon. There's no middleman like an OS eating up precious resources. This gives the developers ultimate control and lets them squeeze every single drop of performance out of that little chip. So we've got the philosophy down, but what about the actual hardware? Let's pop the hood and see what makes this $5 wonder tick. So here are the ingredients. You've got a dual-core processor, which is pretty beefy for something this small. But now look at the memory. 16 megabytes of storage and only 8 megabytes of working memory. I mean, to put that in perspective, a single photo you take on your phone is often bigger than its entire working memory. And yet, this is enough to run the whole assistant, all while using just half a watt of power. It's kind of nuts. And they use that dual-core chip really cleverly. Think of it like a smart division of labor. Core 0 is the communications director. It handles all the networking, the Wi-Fi, the messages from Telegram. Meanwhile, Core 1 is the brain of the operation, dedicated 100% to running the AI agent and thinking about tasks. This separation is key, because it means a spotty internet connection will ever slow down the AI itself. Even that tiny 16 megabytes of storage is managed with incredible efficiency. A sliver, just 24 kilobytes, is used to store your secret credentials. The firmware gets 6 megs, but it's split in 2, which allows the device to update itself over the air. You never have to plug it in again after the first setup. And the biggest chunk, 9 megs, is basically the AI's brain locker. It's where its personality, memories, and all your conversations are stored. All right, so the tech is super cool, but what can this thing actually do? This is where MimiClaw stops being just a simple chatbot and turns into something way more interesting. The real magic is in its local memory system. It's all just simple text files right on the chip. You can literally open up a file called soul.md and edit your AI's personality in plain English. Memory.md is where you store facts it should never ever forget. Your entire chat history is stored locally, not on some company's server. But the two most powerful files here are heartbeat.md and cron.json. These are game changers. This heartbeat feature is what makes MimiClaw proactive. Every half hour or so, it wakes itself up and reads its to-do list from that heartbeat.md file. If it finds a task that isn't checked off, it prompts itself to get it done. Think about that. It doesn't just sit around waiting for you to tell it what to do. It actively works on the goals you've given it. So I bet some of you are already thinking, okay, that is super cool, I want one. So let's talk real quick about how you'd get started, and then we have to cover some really important fine print. Now, if you go out and grab one of these ESP32 boards, you're going to notice it has two USB-C ports. And this leads to the #1 most frustrating mistake that beginners make. You're going to look at it and ask yourself this exact question. And here is the answer. Seriously, if you remember one thing from this whole section, make it this. You have to plug your cable into the port labeled USB. That one connects directly to the chip. If you use the other one, the one labeled COM, the whole setup will just fail, and you'll be pulling your hair out wondering why. All right, time for that fine print I mentioned. This is a really important, honest caveat that you need to understand about what MimiClaw is and what it isn't.
So here's what AI on a chip really means in this context. The agent logic, the part that manages tasks in memory, that runs locally on the chip. Your data, your conversations, your AI's personality, that's all stored locally on the chip. But the huge language model, the actual brain that generates the text, that runs in the cloud. So yes, you still need an API key from a company like OpenAI or Anthropic. And that means there are small, ongoing costs every time the device makes a call to that cloud brain.
But hey, even with that caveat, the whole idea is still amazing. The chip isn't trying to be the massive AI model. It's acting as its ultra-low power, always-on conductor. If what you want is a dedicated assistant that is always available, that keeps your data private, and that you can customize down to its very soul, well, MimiClaw is a genuinely unique and compelling way to do it. And that kind of leaves us with this one big final thought. Right now, we're in this massive arms race for bigger, stronger, more powerful AI models. But projects like MimiClaw, they point to a completely different path forward. What if the next truly revolutionary leap in AI isn't about building bigger data centers? What if it's about distributing intelligence into billions of tiny, efficient, and accessible devices that are everywhere? What if the future of AI is actually less about raw power and more about smart power?